Alright, so in today's video we're taking a look at this guy here. This is a new HD FPV system by a company called Edge Smart Drive, and it's designed to be a rival to the likes of DJI and WalkSnail. Now, you've probably never heard of Edge Smart Drive. I've certainly never heard of them before, but actually it's a sister company to OMP Hobby, which is a company that most of you guys will probably know as being the ones who made the ZMO Pro, a tricopter VTOL fixed wing aircraft that I reviewed a couple of years ago. Now, this system is only $279, which works at around £220. So this is a very, very affordable system. And if it lives up to the hype, this would be an absolutely fantastic option for anyone that's looking to get into HD FPV, but they don't necessarily want to pay the money for sort of like DJI or WalkSnail. So in this video, we're going to be taking a look at this in detail. I'm going to do an unboxing. I'm going to talk you through as many of the specs as I can, and then I'm going to take you out and show you some flight footage, so you can see whether you think this is something that you might be interested in getting for yourself. Let's go. Now, I've written a whole load of notes that I've got written up on my computer here. So as I'm recording this video, you're going to see me periodically sort of looking over there. Also, I've taken a lot of sort of like photos and video clips, so I'll be sort of putting them up in the corner here so you can sort of see as we go. So the first thing we're going to talk about is the unboxing. And as you can see, this is a very nice box that this system comes in. It's very just nicely made. The printing on it is very nice. The quality just looks very, very good. Not that these things really matter, but I always appreciate, you know, a product which comes in nice packaging. Now, in the box, there are then two smaller boxes, one for the camera VTX and then another one for the receiver unit. We'll take a look at the camera first. So when you have a look at this box, again, it looks very, very nice sort of from the outside. On the inside, the foam packaging isn't particularly nice. It's not like molded packaging or anything. It's just sort of cut foam. It's not great, but that doesn't really matter. But in the box, you then get obviously the camera and the VTX unit. You then get a small instruction leaflet, which isn't great in my opinion. It doesn't actually tell you all that much. And then you get a little packet of wires. These are all the wires that you're going to need to set, obviously, this camera VTX up, get it wired to your flight controller and whatnot. My only gripe here is the fact that all the wires are black. They're not coloured, so you have to be very, very careful when you're doing your wiring. Now, moving on to the second box. This is the box that has the receiver in. This is much the same. So in the box, the products are sort of held with this sort of foam. Not the nicest foam, but it's fine. But you get the receiver unit. You then get a little packet of wiring. You get this Ethernet adapter, which we'll talk more about in a little bit. And then you get another instruction leaflet, which again is a little bit basic. This is going to be one of my main points of feedback to Edge Smart Drive, actually, is that the instructions that they provide you with aren't great. And also there aren't really any instructions online. They need to come out with a better manual, which hopefully they'll do at some point in the near future. Now let's have a look at some of the hardware up close. We'll start off by having a look at the camera. Very, very nice looking camera. And the dimensions of this are 20 by 20 by 30 millimeters, and it weighs 13 grams. The camera's got a resolution of 1080p, shooting at 60 frames per second, and it's got a field of view of 120 degrees, which is a very nice wide field of view. Now, the camera is connected to the video transmitter by a 130 millimeter cable. Looking then at the VTX, so the dimensions of this are 36 by 36 by 12 millimeters, and the weight of the VTX is 25 grams. Now, as you can see, the VTX has got two antennas. These are 122 millimeters long each. And then looking around the actual video transmitter itself, pretty much one of the first things you're going to notice is this has actually got a SD card slot. This is something that, you know, us FPV sort of flyers have been wanting in a HD system for ages. We just want a video transmitter where we can just record onto an SD card rather than have to use like silly like adapter cables to access like the internal memory. I'm looking at you, WalkSnail. Or having to like use like a USB connection. You can just use a SD card. And this can take up to a 256 gigabyte SD card as well. So you can have no problem recording all of your flights. Now, looking around the rest of the video transmitter, so obviously you've got this big heatsink here on the top, and this heatsink's also got little holes in it for mounting the VTX, you know, to like your airframe. It's 20 by 20 millimeter mounting, which is a little bit odd considering this is a 36 by 36 size video transmitter, but that's what they give you. And I've got to say as well, on the note of this heatsink, this apparently works very, very well, because one problem that you always get with HD video transmitters is they tend to overheat very, very quickly. However, this video transmitter actually takes a very, very long time to overheat. I did a test earlier, and after 5 minutes of just being left running with no cooling whatsoever, it only reached 63 degrees. Now, I have seen it sort of approach sort of like 80, 90 degrees. That's where I sort of left it for like 10, sort of 15 minutes, but even then I haven't seen it shut down. So clearly this heatsink works very, very well. Anyway, looking around the video transmitter, so I've already mentioned the SD card or the SD card slot. So you've then got a bind button, and you've then got 3 different ports for plugging in connectors. Now, one of these ports is kind of your standard port. So this would be the one that's got the UART on that you'd wire up to your flight controller, a TX and an RX. That's so you can obviously get your OSD information. However, that port also has additional wiring, including an S-bus output. Now, I don't fully understand this, but part of what this this new HD video system is capable of doing is not just transmitting video, but apparently it can also transmit like control link signals, and you can sort of use it to control like gimbals or head trackers, things like that. You may even possibly be able to use it to actually just control your aircraft, like it almost actually works as a receiver. I'm not fully clear on all of those details, but as you can see, this port here also has a S-bus output, and then the other ports on there as well. So there's a Ethernet port, not really sure what that one's for, and then there's another port there as well, which I think this is the one that's used for sort of like controlling the head track or something. I'm really not sure. And like I said, the problem with this is they don't give you particularly good instructions to kind of explain any of this. So I'm having to kind of sort of deduce a lot of this stuff myself. I do know this system is capable of sort of like working with sort of like the MagLink protocol. But yeah, if I find more information, you know, I'll put it on the bottom of the screen here. Hopefully explain it to you. But yeah, so you've got 3 ports on this video transmitter, and then you've also got a little LED here, like a little status LED. So the other things just to mention, so the VTX, well, the VTX on the camera, they can be powered from anywhere between 6 and 28 volts. You've got a very wide voltage range there. That means you can power this from as low as a 2S battery all the way up to, what's that, a 6S? Nice big wide voltage range there. And then the final thing to mention is the power output. So this video transmitter can output anywhere between 20 milliwatts all the way up to 2 watts. And there's a whole load of different increments there. I think there's like 10, maybe even 15 different increments of power settings that you can choose from. So yeah, this VTX has got plenty of power, which is obviously really, really good. So yeah, so that's the camera and the VTX. So let's now have a look at the receiver. So this is a standalone receiver module. It's a little bit like the HD0 or the Walksnail receiver modules. So obviously this isn't integrated into a pair of goggles. You're going to have to use this separately. Now the dimensions of the receiver unit are 82 by 90 by 26 millimeters, and the weight of the receiver is 142 grams. That is a little bit heavy. Even though the unit is quite small, that is a little bit heavy. And it kind of means you're not going to be able to sort of mount this on your goggles. You're going to have to mount this on a tripod or sort of like build like a little ground station around it. Now the reason why it's so heavy is because it's actually got a built-in battery. And this battery is rated sort of between 80 and 100 minutes of use. So, I mean, yeah, you can power this, like charge this thing up, take it to the field, and then you can fly for 80 to 100 minutes with it, which is actually, you know, pretty decent. Like I said, it's a little bit annoying that you can't sort of mount this directly on your goggles, but it is what it is. So just taking a look at the actual device, looking at the front. So the first thing you'll see is there is a fan. It's got a pretty powerful fan on board this thing. It's a little bit loud, but not obnoxiously loud. And you'll see around the device as well, there are little air intakes. Now, the other thing that you're very obviously going to notice is that this thing's got built-in antennas. There are 2 patch antennas on the top. Haven't been able to find any specs about these antennas other than they are directional. You can kind of tell that because they're patches. But I haven't been able to find any information about sort of like the beam width or the gain or anything like that. Although, as you'll see in a little bit, they are apparently very, very good antennas. So, looking around the device. So we'll start on the left-hand side. So on this side, we'll see that there are 2 buttons. There's a power button, which is also used as a menu button. And there's a second button, which is used as a select button. This is because when you've got this device connected up to goggles or a screen, there's actually a menu you can access and use these buttons to kind of cycle through the menu. We'll talk more about that in a bit. The only other thing that's then on the left-hand side of the receiver unit is then this USB-C port. And this port is used entirely just so you can charge the inbuilt battery. There's nothing on the back of the receiver other than these little holes here, which I think might be designed for sort of like mounting it to a bracket or something. There's also nothing on the bottom of the receiver. On the right-hand side of the receiver though, this is where you've got your interfaces. So you've got a Ethernet port. This will connect to the Ethernet wiring adapter that came in the box. We'll talk more about that in a little bit. There's then this other port here, which I'm really not sure what it's for. I mean, like, the instruction manual, again, doesn't really explain it. But I'm wondering if possibly it's so it can be used with like a tracker or something, because it mentions sort of like servo outputs and sort of there's a UART and stuff. So yeah, possibly it's used with like an antenna tracker. Not really sure. And then the only other output on the side of the goggles here is another USB-C port. But this is the one where you actually get the video signal out from the receiver, which will then send to your goggles. So that now brings me on to talking about connectivity. And this receiver unit allows you to get an image out of it in 3 different ways. Now, the main primary way is going to be over HDMI, using that USB-C port. But you can also use Wi-Fi, or you can also use Ethernet. Now, we'll talk about HDMI first. So you need a special cable. You need a USB-C to HDMI mini cable. It's really annoying that they don't provide this, with the kit, because it's absolutely essential you have this cable. You're not going to be able to do anything with this receiver unit unless you have that. So it would be really nice if they included that in the kit, especially because those cables are a little bit expensive. Once you've got one of those cables though, what you can then do is you can connect it directly to a pair of compatible goggles. Now I use, I've got a couple of different pairs of goggles. So I've got SkyZone Cobra X V2 goggles, which are analog goggles. However, these do have a HDMI import and it works very, very well. Literally just plug the cable into the goggles, put the goggles into HDMI mode, and then straight away, you've got a perfect image coming in. Now, the only problem, and this has been a bit of a thorn in my side whilst trying to work on this, is that the SkyZone Cobra X V2 goggles do not allow you to record DVR when you're in HDMI mode. Now, for the average person flying, that might not be a big deal, but obviously for me, when I'm trying to do a review, I want to be able to get kind of footage that I can then show to you. The fact that I can't record DVR is a little bit of a problem. Now, the way that I've worked around that, you'll see this more in a little bit, is I've ended up using a FPV screen instead. There's plenty of FPV screens out there that have HDMI imports. And then I literally just set up a camera in front of the screen so I could record, what the screen was seeing. Far from an optimal solution, but that's what I ended up doing. Now, I do have another pair of goggles. I've got the Walksnail Goggle X goggles, which have a HDMI import. However, due to the design flaw in those goggles, it's actually almost impossible to get a HDMI cable to properly sit in the connector in the goggles. And also, those goggles do not allow you to record DVR when you're in HDMI mode. And I've Googled this, and it turns out that pretty much every pair of FPV goggles out there that support HDMI in do not allow you to DVR the HDMI feed. That's just something that you need to be mindful of. If it's important to you that you're able to DVR your flights, you're going to need to work out a solution, possibly with a like a capture card or something. That is something that I would have probably done myself. However, because it's the Easter holidays at the moment, everywhere's shut. I couldn't find anyone that had one in stock, and I wanted to get this video out sort of sooner rather than later. But yeah, so HDMI, that's the main way that you're going to connect this receiver to, goggles or a screen, and it works very, very well. However, DVRing your footage may be a problem. Now let's talk about the other connectivity options. So Wi-Fi. This device has the ability to transmit the video signal simultaneously, as well as HDMI. It can simultaneously broadcast it over Wi-Fi. The way you do that is you have to access the menus on the device, which I'll show you a little bit more later on. And then you have to select a Wi-Fi frequency. They give you a whole load of different ones. I think that's because in different parts of the world, different frequencies are used. So you've got to kind of go through and sort of choose a frequency which kind of works for you. You can then, on your phone or tablet or computer, you can download Q Ground Control, a little app, a little bit of software, and then you can program in some settings, which I'll put on the screen here, which will then allow you to then get the video feed broadcast over Wi-Fi to your phone or tablet or PC. Now, the only problem with that is it's rubbish. So as you can see here in this video clip, the Wi-Fi image that's appearing on my phone is extremely laggy. You absolutely would not be able to use this to fly with because it's very, very laggy. Every now and again, it will work absolutely fine, and then it will just go really slow. It will pause, it will freeze. It's just completely unreliable. Weirdly though, on one occasion, I actually got the Wi-Fi to work extremely well. I had a really good, really smooth, really fast stream coming through to my phone. But then what I found happened instead was that the HDMI feed on my goggles then started pulsing on and off. No idea what's going on there, but for whatever reason, you can't have a working Wi-Fi image on your phone and also have an HDMI image on your goggles. You have to choose one or the other. You can't have both. Basically, I don't really think that the Wi-Fi functionality works well enough to really be a feature. Hopefully it's something that they'll improve at some point in the future. But yeah, for the time being, I wouldn't bother even thinking about using it. Now, the third connectivity option is using Ethernet, and I have tested this, and this actually does work very, very well. So on my PC that I've got here, there is a Ethernet port in the back. So all I did was I connected the Ethernet adapter to the receiver unit. I then had to get an Ethernet cable, which literally cost me £1. Connect that to my computer. Again, I then loaded up Q Ground Control on my PC, had to put in a couple of settings. And then, yeah, I was able to get a very nice image, appear on the screen, which had, pretty much no latency that I could really sort of see. It worked very, very well. Now, there is a problem with that though. Obviously, I can't take my PC with me when I go flying. And these days, it's very, very rare to get a laptop that has a Ethernet port on. Now, if you've got an older laptop with an Ethernet port, then, yeah, this could be an option. You could take your laptop, to the flying field, and you could run this connection through Ethernet. I don't know this for sure, but I think technically the Ethernet connection might be slightly quicker than the HDMI connection. I might be wrong about that, and if I am, fair enough. But yeah, there might be advantages to running a Ethernet connection. However, one disadvantage, aside from the fact obviously taking a PC with you to a flying field or a laptop might not be convenient. One other disadvantage is that for some reason when you use the Ethernet connection, you don't get OSD. I don't know why that is, but you don't get any OSD whatsoever. So all you have is the image, which looks very, very nice, but no OSD, which may be problematic for flying, just because you won't know sort of the battery voltage of your aircraft, if nothing else. But yeah, so those are the three connectivity options. It does say on their website that you can also connect the receiver to a device using just a standard USB-C cable. However, I've not been able to get that to work. I've tried that on my phone, my tablet, my computer, and also my FPV monitor. I can't get any image out over USB-C at all. So yeah, if you're going to buy one of these devices, expect to use it with HDMI. That just seems to be the way to go. It works very, very well. You get the full OSD with that mode as well. That would be the best option. Okay, so now I've explained all of that, let's now talk about my experience of actually using this system. And I think the first thing I need to do is explain to you my setup. So as you can see here, what I've ended up doing is I've sort of built myself a bit of a ground station. That's because, as I mentioned earlier on, I can't DVR any of the flight footage when I'm using my goggles. So what I've done is I've built a system here where I'm using a FPV screen. I've got the receiver unit mounted on the back. This is all held together with sort of a 3D printed mount that I've designed. And then, yeah, I've just got a camera positioned in front of the screen to record the screen. As you'll see in a bit, this doesn't work particularly well, but it's the best I was able to do, especially given sort of like the short time frame that I'm working with. As for an aircraft, I've actually got the camera and the video transmitter installed on a quad. This is a SpeedyBee B25, which was sent to me by SpeedyBee last year for review, and I never got around to it because I'm a terrible person. Sorry, SpeedyBee. But yeah, this is the quad that I've got the system installed in. I am going to be installing this in a fixed-wing aircraft at a future point, and there will be a part 2 video. But yeah, for the time being, I've got it installed in this quad, and this is what I've been using for the testing. Now, before I show you any flight footage, I just thought I'd show you a quick tour of the interface that you actually get out of the receiver that you end up actually seeing on your goggles or your screen. So as you can see, you get a very nice OSD, and this is an OSD which is actually just programmed at the factory, and it's set up by default ready to use. This is a full color graphical OSD, which looks very, very nice. It's got all of the sort of the key information that you're likely to need to sort of displayed around the screen. And it's also fully customizable. You can access the menu, you can reposition any of the elements you want, you can add elements, you can take elements away. It's fully customizable, and I actually really, really like it. My only complaint is that the sidebars and the horizon bar is a little bit faint and it's a little bit hard to see, but everything else just seems to work very, very nicely. Now, as I said, you can access a menu on the receiver unit using the buttons on the side. And there's a whole load of different settings in here that you can change. So you can change the Wi-Fi settings. You obviously need to choose the Wi-Fi frequency, as I mentioned earlier on. You've got the option to do that. You've got the option to change the band and the sort of the channel that the system is broadcasting on for the standard FPV link. You've also got the option to change camera settings and also receiver settings, which is something I haven't really figured out yet. There's a whole load of different settings that you can access via this menu. It's all laid out very, very nicely and all works very, very well. Now, when you power on the aircraft and you get that connected, you then obviously get the FPV feed image appear behind this OSD, and it looks absolutely fantastic. The image quality from this camera is actually very, very nice. It's a nice colourful image. It's nice and sharp. It's got good wide dynamic range. I don't really have any complaints with the image quality whatsoever. It seems to work very, very well. Now, it does say in the limited instructions that you get that you need to bind the video transmitter to the receiver the first time you use it. And that's done simply by pressing the bind button on the receiver and the video transmitter at the same time. However, I found that mine was already bound, straight from the factory, and you may find the same thing yourself. Now, I know that someone out there is going to ask about latency, so I did do a latency test. I did this in the same way that Joshua Barbell tends to do this, where I set up a timer on my phone. I then used the camera on the quad to film the timer on my phone. And then I simultaneously filmed my phone and the FPV screen from a distance. You can see the time on both. And it's advertised that this system has a latency of around 60 milliseconds. However, I found, certainly with the quad right beside the receiver unit, I found that I was getting a latency of around sort of like 13 to 14 milliseconds, which is considerably lower than what is advertised. Now, obviously, that might be a little bit different when you're out and about and flying, but that's obviously a lot harder for me to measure. But yeah, certainly right here on the bench, latency of around 13 to 14 milliseconds. I think that's very, very good. Okay, so anyway, now I've explained that to you, let's get to the most important part of this video. Let's actually look at some flight footage. So I went out yesterday and I did a flight in the middle of the day. It was a very nice sunny day. It wasn't particularly windy. It was pretty much perfect conditions for doing a test. Now, just to explain, I wanted to kind of give the system like a proper test. So I chose a location to do this flight, which is in a park which had a lot of trees. I positioned myself very much amongst the trees with my little ground station there. And then I did a flight where I kind of weaved all around the trees. I also flew not only in front of the ground station, but I also flew behind, just so I could really test the system and see how good the system was at actually getting a signal to penetrate, through all those obstacles, and also, how good the antennas are at receiving the signal from behind. For the entirety of the test, the ground station was in a fixed position. The antennas were facing, forwards the whole time. I didn't adjust the ground station. The antennas faced in one direction for the entirety of the flight. So what you're seeing at the moment is footage which was recorded directly onto the SD card on the VTX whilst the quad was flying. And this is actually something I think is really important to mention. And it's a really nice feature of this system is the fact that as soon as you power on the aircraft or power up the video transmitter, it starts recording straight away and it won't stop recording until you power off the aircraft. Now, what's more important is the fact that it will keep recording even if the aircraft loses connection with the receiver unit. Normally with HD FPV systems, if you lose signal, the recording on the aircraft also simultaneously stops, which is just really, really annoying. I don't know why most HD systems do that. But that's not an issue here. As you can see, like this recorded the entire way through, non-stop. Even if the signal got a little bit low, it just worked. It recorded the whole time. I absolutely love that as a feature. Now, it would be nice if maybe the recording started when you armed the aircraft and stopped when you disarmed it, rather than just record the whole way through. But the fact that this video transmitter can take a 256 gigabyte card means it's not really going to matter if you end up recording a little bit of pointless footage at the start of your flight whilst you're potentially waiting for GPS satellites or something. It's really not going to be a problem if you fill up your card because you've got such a big card, you've got plenty of memory to spare. Now, as I explained earlier on, because I can't DVR my footage when using HDMI, I had to set up this bizarre little system here where I sort of position the camera in front of the screen so I could try and record the footage that I was receiving in real time. Now, unfortunately, this didn't work very, very well. For a start, because it was a sunny day, there was quite a lot of reflections sort of hitting the screen. I sort of tried my best to sort of hide them, with this little DIY lens hood I made, but that didn't really work very well. But also annoyingly, I didn't realize this when I set it up, but actually the camera was a little bit too close to the screen, so therefore everything was a little bit out of focus. Now, we'll leave this DVR recording sort of playing in the corner anyway, even though you can't sort of see it, sort of super well. The most important thing that I want you to be able to sort of appreciate is that for the entirety of this flight, at no point did I lose signal. At no point did the image freeze, or did it stutter, or did it do anything weird. I actually had a perfect signal for the entirety of the flight, which actually I was really, really impressed by. As I said, I was sort of flying around trees. I was doing sort of a little bit of distance whilst also flying around trees. And I also spent quite a lot of time sort of flying behind myself as well. But at no point did I lose a signal. It didn't sort of distort. It didn't pixelate. It didn't freeze or stutter or do anything like that. It just worked perfectly the entire time. Now, this system can do up to 120 megabits per second. Obviously, you're never going to get that in flight. You're only going to get that whilst you're sat on the bench. But throughout the flight, on average, I was sort of seeing between sort of like 30 and 70 megabits per second. However, on more than one occasion, I dipped just below 10 megabits per second. I think I hit 8 or 9. And even then, the system still worked absolutely perfectly. The image didn't distort. It didn't pixelate. It just worked absolutely great. So I was actually really pleasantly surprised with how well this worked. I've been using the Walksnail system for 2 or 3 years now, and that system's always been very good. But I can guarantee you that I wouldn't be able to sort of pull off the same flight using that system. Certainly not without sort of moving my head. There's no way that I'd be able to sort of fly around trees behind myself using the Walksnail system. Certainly not as well as I was able to do with this system here. So yeah, I was very, very impressed. Now, obviously, I was kind of interested to know, well, what does happen, if you do lose signal. So back home, I did do a little bit of a test. So I live in an apartment building and I live on the 4th floor. So I did an experiment where I just set up the receiver unit. I just left it in my living room and then I powered on the quad and then I just went for a walk down the stairs. Like I said, I live on the 4th floor, so I had to descend 4 flights of stairs. This is after leaving my apartment as well. So, I descended down a long way. There's a lot of concrete, there's a lot of metal, there's a lot of walls between me. But I actually managed to make it all the way down to the ground floor lobby, which, is quite a long way away from sort of where I actually had the ground station positioned. And it's only when I reached the ground station lobby that I eventually lost the signal. And it happened when the bitrate reached about 5 megabits per second. At that point, that's when the system just couldn't obviously maintain the link. And what you see is that the image actually freezes. Now, I don't love that. Obviously, you know, we'd all prefer for like the signal to slowly deteriorate like it would do with analog. But yeah, as you see, the image does just entirely freeze. Amazingly, there was no sort of like breakup or distortion on the way there though. The image didn't sort of slow down or get laggy or anything like that. You know, it worked absolutely perfectly right up until the point where it stopped working. In some ways, that's really, really good. I guess it's really, really impressive that the signal was able to hold on that long. But the downside is that unless you're paying attention to your bit rate, you're not going to know that you're about to lose signal until you do lose signal. It'd be nice if maybe this system incorporated something like the Walksnail system does. I don't know whether DJI does this, but Walksnail, if your signal's getting low, you actually get this like red box around your image to let you know it's getting low. It would be nice if maybe Edge Smart Drive could incorporate something similar to that. But also, just talking about obviously losing the signal, regaining the signal, as soon as I sort of started walking back up the stairs, I think I descended maybe 2 or 3 stairs, and the image just came back straight away. It didn't take very long at all, you know, a second or 2 at most for the signal to come back. So yeah, I just thought you guys would be interested to know, you know, what happens if you lose a signal or if the signal gets low. Apparently it will freeze entirely, which isn't great, but then it will come back very quickly as soon as the aircraft is back in range. Now, I did do one other flight with this aircraft. If you've been a subscriber to my channel for a while now, you'll know that I quite enjoy flying in the dark. And it is advertised on the Edge Smart Drive website that this system is supposed to be very good at sort of having some night vision. So obviously, I was very keen to try that. So yesterday evening, I went out for a flight. It was about 45 minutes after sunset. And we are sort of coming up on summer now, so it wasn't fully dark. But it was certainly, you know, pretty dark. And yeah, I just did a very quick little flight just around this field here. Now, the image at first didn't actually look too bad. You know, as I took off and I flew down the field, I could actually see quite a lot of detail. And I'd argue maybe I could see just a little bit better than what I could see with my eyes. There was a couple of goalposts in the field, and I had no problem sort of like flying sort of down towards them and sort of like through them safely. And yeah, initially I was quite impressed with the image that I was seeing. However, when I turned the quadcopter around to fly back up the field, and this was in the direction that the sun was setting, that's when things fell apart. Because the sky was a little bit brighter in the distance as I was flying back, it completely messed up the wide dynamic range, and it made it almost impossible to sort of see the ground or any details as I was flying back up the field. You know, the goalposts that I had no problem sort of seeing as I flew down the field, I completely couldn't see them as I was flying back up the field until I was almost completely directly on top of them. So yeah, despite initially being very impressed with the low light capabilities of the camera, I actually very quickly realized that actually they're not that good. Now, as I mentioned earlier on, you can access a menu on the receiver unit, and through that you can actually program some camera settings. And one of those camera settings is for the starlight settings. Now, I don't fully know what this does, but there's 4 different starlight settings. By default, it's set to 1, but you've also got 2, 4, and 8. So obviously, I just experimented by changing those settings to see what would happen. And ultimately, as far as I can tell, all it really changes is that the image gets brightened a little bit. But it's not really sort of like actually changing any exposure settings or anything on the camera as far as I can tell. It's literally just brightening the pixels just to make the image, well, literally just a little bit brighter. But it's not actually doing anything, you know, on the camera itself as far as I can tell. I think the change is entirely happening on the receiver end. Because despite trying all 4 of the different starlight settings, I wasn't able to improve the image quality in the dark at all. And so every time I sort of flew down the field and then back up again, I completely couldn't see and just didn't work very well. So yeah, I think I have to conclude that the T3 system just doesn't work particularly well in the dark. But actually, when I was back at home, I did a test out the window where I compared the T3 system to the Walksnail Alpha Pro camera. That's pretty much universally regarded as being the best night vision HD camera. And yeah, whilst you get sort of like much better colors sort of out of the T3 camera, you just can't make out anywhere near as much detail as the Walksnail camera. So yeah, I'd have to conclude that yes, you can use a T3 in low light, but I wouldn't really sort of recommend it, and certainly don't try and use it in the dark. It's just really not that good for it. So anyway, those are the only 2 flights I managed to do with the system so far. But actually, I've got to say, I'm actually pretty impressed with this. I'm not going to lie, like I didn't have especially high hopes that this system would be particularly good, because it is, you know, comparatively very, very cheap compared to sort of the likes of like Walksnail or DJI. And because it's made by a company that isn't sort of especially well known, I didn't think this system was going to sort of work particularly well. But actually, you know, from the limited testing I've done so far, I've actually been very, very impressed with it. You know, the fact that I was able to do that sort of that flight around the park and, you know, sort of fly behind all those obstacles and sort of behind myself and have a perfect image, you know, for the entirety of the flight, that actually, you know, really surprised me, and I'm actually very impressed with it. The build quality of all the hardware seems to be very, very nice. The image quality from the camera, other than at night time, I really have no complaints about it so far. There is one thing actually that I have forgotten to mention so far in this video. So the flight footage that's saved onto the SD card on the video transmitter, although the footage, you know, as you saw, looks very, very nice, it's recorded in a really annoying format. It's recorded as a .ts file. I've never heard of that before. I don't know why they don't just save it as like a normal MP4 file, but they don't. They use a .ts file. And for me to be able to sort of get this footage to you, I had to convert it not once, but twice. I had to convert it once using VLC player into a different format, and then I had to then use DaVinci Resolve to then convert it a second time to then get it into a usable format that I could then put into my video editor. That's really annoying. I don't know why they've done that. And I really hope they change that, because it's really annoying that you have to convert your footage to be able to sort of edit it, to, you know, put it online. Yeah, stop using a .ts file format. Change it to just a normal MP4. That would be, you know, a lot nicer. But yeah, other than that, I think my only other gripe is the fact that the system doesn't come with the USB-C to HDMI cable that you need. I really think that they should include that in the kit. And also, it's just a little bit annoying that the receiver unit is, you know, a little bit too big, a little bit too heavy to be installed on goggles. You pretty much have to install this on a tripod. You don't necessarily have to build a ground station like I did, but you're going to have to, you know, install this on a tripod to be able to use it. It'd be nice if maybe they can make the system a little bit smaller or a little bit lighter, just so it could be incorporated into goggles. But, you know, Walksnail, when they first came out, the first thing they brought out was a module, and after that had some success, they then brought out some goggles. So hopefully the same thing will happen here. Edge Smart Drive will, at some point in the near future, bring out a T3 pair of goggles, you know, and that would be very, very nice. So yeah, so that is basically everything I've got to say for this video so far. Like I said, there is going to be a part 2, because, you know, I am a fixed wing pilot and I want to test this system on a fixed wing. And it's going to be much easier to sort of test how well the system sort of operates, you know, over a distance with a fixed wing as opposed to a quad. So yeah, keep an eye out for a part 2 video at some point in the near future. But I hope you enjoyed this video and, you know, the information I've given you so far. If you have enjoyed it, as always, please do give it a like down below. And yeah, I guess I'll catch you in the next video. Cheers, guys. Bye.